Okay, welcome back. We are now starting a new session. And, Michael, can you drop your presentation? Because I have something to share first.
There we go.
Thank you. Oh. Just a second. Okay, thank you, everybody. We are here for the industrial engineering section of the workshop. And I remind you that we are going to record these sessions as everything else in these 3 days. The slides will be also shared. Everything is deactivated from your side, so don't worry about this. But during the question answering session, we can bring you on stage if there is a need. After the talk, it is organized in this way. We will have the 3 presentations. I will introduce the speakers, and we collect the question at the end with a common discussion. If you have any clarification question, you can raise during the presentation. I will take charge of asking the speaker to answer them. The industrial domain ontology, which is the focus of this session I'm chairing today, is of course one of the central issue in the OntoCommons project. We will have, and we are collecting community input to formulate guidance and agreements, because the goal at the end for the ecosystem to work is to achieve some decent level of harmonization in the domain in order then for everything to work smoothly and little by little improving the system and the services they can provide. The harmonization requires development, testing, validation, agreement procedures, and this is the focus also for this session. I will present later on the objectives. Essentially, you can see them through the presentations. So we have an expert on competency questions, and we have expert in simulation and use of domain ontologies. I will introduce them little by little during the first part of the talk. So just wait a moment, and I will tell you something more about the different people. After this session, there will be another presentation at 4 o'clock. Of course, a mandatory break for everybody. You have the information here, and there will be also a recap of the different sessions we have today. And now, let me tell you a little bit about Michael Duninger. He's a computer scientist, professor of industrial engineering at the University of Toronto. He leads the Semantic Technology Laboratory. He has been visiting in different roles, the University of Maryland, the National Institute of Standards and Technology. He has been president of the International Association of Ontology and coordinator of several ISO standards. Primarily, you probably know him for the PSL standard, and then more recently for the ongoing top-level ontology standards, both of ISO. His research interests are in formal characterization and application of theory from mathematical logics in the area of manufacturing and enterprise engineering. And at this point, Michael, if you're ready, you can start your presentation. Thank you.
Thank you, Stefano. Great to be here at OntoCommons. And just starting the screen. Okay, great. So today I want to speak briefly about the role that competency questions play in the design of ontologies. And I mean, the primary motivation for this is the question, what axioms do I need in my ontology, right? What are do I have the right axioms? And even more importantly, how do I know when I am finished? One of the big challenges of ontology design is that people often don't know, well, how long do we need to design this ontology? How many more axioms do we need to say that we are done? And the key here is to realize that ontologies are designed artifacts, right? We specify their requirements at the beginning of the life cycle. So just like in software, right? But for ontologies, we're referring to the semantic requirements. And there's an ontology lifecycle analogous to the software lifecycle. So since ontologies are these designed artifacts, we specify their semantic requirements at the beginning of the lifecycle, and then use these requirements as the basis for evaluation throughout the life cycle, right? Again, analogous to software engineering, where we have the functional requirements, and one way of specifying functional requirements is in terms of tests. So you can always test out your system to see whether they satisfy the requirements. Right? And so when we're thinking in terms of ontologies, right, this idea of what do you mean by some kind of semantic requirements? The key is to realize that any consistent axiomatization of ontology will have some non-empty set of models. And so what we're specifying with requirements is to say, well, which of these models are the ones that we intend to be the models of our ontology, and which of these are the ones we do not intend. And the whole effort of ontology design is to come to an axiomatization of our ontology that matches those intended models, as I'll say in a few minutes. So one way of specifying these requirements, I say in the analogy to software engineering, is very often you specify functional requirements in terms of tests that you will use against your system. We can think about, well, what would be the analogy then of tests for an ontology? And this is where the whole idea of competency questions arose, that they were effectively tests or queries that the ontology must be able to entail. And so we use competency questions as a means for implicitly characterizing that set of intended models. Like I said, that if we think of these requirements as being the models that we want to have as being models of our ontology, then the questions serve as a way of implicitly characterizing those. Because the idea is that any sentence that should be satisfied by all of the models that we want, all of the intended models, those are the ones that will be provable from the axioms of the ontology. And so far as that's true, then we can use that as a test, right? So we have a particular question that we want to be able to ask. And if it really is true in all of the intended models of the axioms we have at a particular phase of the ontology lifecycle, then it should be provable, right? And if it's not provable, if you can, in other words, if your current version of the ontology fails that test, then some kind of unintended model will pop up, and you can then see, okay, well, how did this happen? And you can add axioms to your ontology, to improve the ontology so that it passes the test. Now, one of the things that we noticed when we first introduced the idea of competency questions is people thought of it as being, sort of like just database queries. Now, this is kind of a weak way of using them. Like one of the roles that a competency question can play is simply in terms of identifying, like, what's the signature of your ontology. But when people are just using it as a lookup query, that's not really the best use of the questions, because all you're doing is retrieval. However, that idea is kind of close to how we would kind of think about it. And one of the things that we've been looking at more recently in terms of design of ontologies is actually focusing in on the data, right? So if I have, some of these are, say, some triples from a knowledge graph. Alice lectures Math 456, which is a science course. Bob teaches MIE 123, which is an engineering course. Right now, if I ask, well, is Alice a professor in the math department? Or is Bob enrolled in any courses? Just from that data alone, right, if you're using database lookup, you would not be able to answer those questions. And this is sort of the key to understanding how to use data and Competency questions in the design of an ontology. You're not using them to simply do a lookup, right? So I'm not asking, who lectures Math 456 or what courses does Bob teach. There's actually some background knowledge here, right? In order to answer the question, is Alice a professor in the math department, you need to have some background knowledge that a professor is someone who lectures, right? And if I want to, in order to answer the question, is Bob enrolled in any course, I need to understand what does it mean to be enrolled. And if someone who teaches a course is also like an instructor, can someone who is an instructor also be enrolled in a course, right? So the point here is that this background knowledge is needed to answer these questions from the data. And that is precisely that background knowledge that we would be testing with the competency questions of your ontology. So in this case here, the ontology is axiomatizing the intended meaning of these phrases, like these relations like lectures, class, and lectures, and relations like enrolled, and also classes like professor, kind of idea, right? So what does it mean to lecture? What does it mean to teach? What does it mean to be enrolled? What does it mean to be a professor? And that would be what we would be testing with the competency questions. And another way of kind of looking at this, right, is in terms of what are some semantic requirements. Another way of looking at this is you can use data sets themselves as representing the intended semantics. So effectively, examples are things like clean data sets that have no errors, and therefore should be considered to be consistent with the ontology. And effectively, they could be considered to be a way of, again, an implicit way of specifying the intended models of your ontology. Whereas counterexamples would be, say, data sets that have quality problems. And these are then cases where they should be inconsistent with the ontology, right? And because, say, for example, if there's a constraint that says, only professors can teach a course, and but then David is a student and David is teaching the course. Students are disjoint from professors. That would be an example of a data set with a quality problem, right? That should be inconsistent because it's falsifying this constraint that says students cannot teach a course. And that would be an example then of some background knowledge that's implicit in the data sets and which you would want to make explicit within the design of the ontology, right? And that's the whole idea of what we're trying to do here with these requirements, is identify what that implicit knowledge is. Now, you can also specify these intended models kind of explicitly, which is work that we do in our lab, where we use existing mathematical theories for things like orderings, mereologies, graphs, magmas, which are generalizations of algebra, incidence structures, which are generalizations of geometry. You can do that, and that's another way of doing it. But for today, I want to kind of more focus on this idea of kind of using data sets. And this classic diagram from Nicola Guarino's work, kind of captures again what we're trying to do here with the ontology lifecycle, right? That you have the actual models of your ontology, and then you have the ones that are intended. And what we're doing with competency questions and these other ways of specifying semantic requirements is determining, first of all, is there a difference between the actual models of your ontology at some point in the life cycle and the intended ones, right? Sometimes there are models that are unintended, that they're consistent with your ontology, but you don't want them to be. Other times there are models that you want to be intended, you want them to be models of your ontology, but they are actually inconsistent with your ontology, so they're not models. And we call those omitted models, right? And the whole idea of ontology design is to ensure that the models of your ontology are actually your intended ones. And so ontology verification is this procedure, this methodology by which we determine is there a mismatch between those two. And the idea of using competency questions is a way of leveraging theorem proving to support verification, right? That, as I said before, if you can entail your competency questions, that means that the logical formula corresponding to that competency question is actually satisfied by all of the models of your ontology. And since you want your questions to be true by all your intended ones, it will also be true for all of your actual models. There's another approach where you can use theorem proving. Like say if you've specified your ontology with these mathematical theories, you can use what's called logical synonymy, where you can write translation definitions between the signature of your ontology and the signature of some collection of mathematical theories, and show that they actually are equivalent with respect to those definitions. Right, but all of this kind of follows from, I'll skip over this idea of soundness and completeness, but this is all kind of due to the soundness and completeness of say, first order logic, and any restriction of first order logic, like the various description logics and web ontology languages. That when you have a logic that's sound and complete, what that means is that a sentence is derivable from your axioms if and only if it is entailed by that axiomatization. In other words, it's satisfied by all possible models. And that is what really allows us and guarantees us this idea of being able to use competency questions as a kind of an effective test. Now, what you see on the screen here is sort of a kind of the methodology that we follow when we are kind of testing an ontology against these queries, which are the competency questions. If like I'll kind of maybe move to let's see, I guess case 3 would be where you actually find a proof. You're good. You can kind of move on to the next question. What happens in case 2 is you don't get a proof, right? So you try to prove entail the competency question, but it doesn't actually. You don't get a proof back. Now, one kind of problem with first order logic is the kind of the semi-decidability. So in a sense, when you don't get a proof, you're not quite sure whether or not it truly is provable or not. But what you can try to do is construct a counterexample. Use software like Mace or Darwin, Paradox, Vampire to actually try to construct a counterexample. And if you can construct a counterexample, then again, you have an indication that, okay, our ontology is missing some axioms, and we need to extend our axioms to repair that. Sometimes in case 1, you actually get what's called an unintended proof. So you think you're answering your competency question, but if you actually look at the proof, you're actually proving something different. You're proving a sentence that's stronger than your competency question. And that's why we call this an unintended proof. And it's an indication that you have omitted models. Now, there's another final question, which I'll just try to get in the last couple of minutes here, which is this idea of ontology validation. So if ontology verification is concerned with the relationship between the models of your of the axioms of your ontology and the intended models of your ontology, ontology validation is asking, well, do I even have the right intended models? In other words, am I asking the right competency questions? And this is really something that we found is something that's needed with a dialogue with the ontology designer, right? How do we enter into this dialogue? And I think this is sort of the next sort of frontier that we need to really be focused on within applied ontology, is engaging in these kind of dialectic techniques to determine whether or not the questions that you're asking, those competency questions, are indeed the right kinds of questions, right? So again, analogous to software engineering, we want to look at validation, right? And so then again, you have this entire ontology lifecycle. So that's a short snapshot of some of the ways that you can use competency questions to do ontology verification. But I think even more challenging problem is a whole idea of validation in order to say, what are the competency questions that a particular ontology needs to address? Thank you.
Thank you, Michael. Very interesting. I remind people to write their question in the tab, in the Q&A tab, so that we remember them later on when we do the common discussion. And at this point, we'll would like to have Walter Takai on the stage. So Walter Takai is a senior researcher at the Stima Institute in Milan. The Stima Institute is one of the institutes that are part of the National Research Council in Italy. He has been working on ontology for a long time, and I also I'm happy to report that we did interesting work together. At least I think it is interesting. But here is he's presenting something that is a part of his own research, and in particular, he's interested in the studying and modeling of production systems in the scope of digital factory applications. He employs semantic web and VR technologies in research products and academic teaching. And Walter, you can start whenever you're ready. Thank you.
So thank you, Stefano, for introduction and for the invitation, first of all. So here is my short talk. Indeed, I've been working since some years with ontologies, but I'm still more an engineer trying to use ontology than a real ontology, so ontologist. So my talk will be more focused indeed on practical applications. As you see, this is my reference slide. What I'm dealing with is application of digital technology to the factory domain, and focusing mainly on interoperability of digital tools. So the idea is to exploit ontology to enhance and foster interoperability, guarantee coherence of evolving models, and also a synchronization between real and digital factory. That is indeed a topic very relevant in the scope of Industry 4.0, and we see probably also 5.0. And in this slide, just a few examples of possible categories of digital tools related to simulation, visual representation, of course, AI algorithms. All these application tools are based on their specific model that is typically just a perspective of the more complete descriptive model of a factory, in our case, but more in general, any kind of engineering system. And so that's the key motivation why a few years ago I started working with ontologies, trying to exploit them in industrial engineering application, and more specifically in manufacturing, about the design and management of production systems. So this is my main research area. And so here you can see listed a few of the key requirements that semantic web technologies, more in general and more specifically ontologies, can help to cope. And in particular, the need to integrate multiple data sources of different type, and also linking together data that are very much heterogeneous, but still needed to be covered to address manufacturing problem in a sufficiently practical way. So this is the key driver for using ontology. At least it was for me. Since I knew that Michael would give a talk about the competency question, also I made an addition to my slides. Of course, these are entry-level competency questions, so it's missing the more advanced part that Michael was presenting a few minutes ago. But I thought it was useful only how to give an idea, a flavor of what I just said about heterogeneous, how much heterogeneous are data that we need to consider when dealing with factory design and management, more in particular, or more in general with manufacturing and industrial engineering. So going quickly, since we don't have much time, we need to represent and being able to answer questions about the product, so the part type that our production system is supposed to produce, how we are going to make these to get this output, this intended output, so the process plan, process steps, which is the present and relations between these process steps, and also more important, which are the capability requirements that we need. And this, for example, is one of the most recent research topics that I'm also happy to be addressing together with Stefano. But not only this, we have a system, a production system. So how can we compose our production system? So which are the candidate resource that we can include? But for each of these resources, we need also many more details, ranging from their properties, their capabilities that can be matched with the process steps requirements, also which are their performance, so which are also their geometric representation, 3D models. Of course, also I'm a bit biased because one of my other research topics is related to virtual reality, so I always keep an eye on also this aspect about visual representation of what we are dealing with. But not only this, also much important for the analysis and the design of production system is to know about the states, the possible states of our production resources. So failure states, but not only, maintainability and reliability, and so on. And then we need to put everything together, so to have a proper system. So how we define relations between the elements composing the system, how they are placed on the layout, so again, topology, geometry, and so on, and so on. But it's not over yet, of course. I'll be quick on this one. Not only the hardware part of the system is fundamental, but also how we control and manage the system itself. So production planning, control, definition of batches, production batches, maintenance, and so on. So I think it's clear enough how indeed it's heterogeneous, this domain, this wide domain, and so how can be even quite challenging to have an ontology, or better, as we're going to see in the next slide, an architecture of ontology modules that can help to tackle this domain. And so here I'm coming with a proposal, or better, a possible integrated architecture of ontology modules. This is what I've been working on personally in the last few years. It's not per se a standard, so of course it's subject to evolution, refinements, and that's what happened actually it keep on happening also in the last few years and months. So you can see there is a mixture of different ontology modules. In the next slides, I will give a few glimpses and also categories of these modules. But this is just, again, to stress how it can be really difficult, I would say impossible, to find just one ontology that is able to solve completely a problem that has relevance for industrial application, real industrial application. And so going quickly through the architecture, here we have one of the cornerstones of the current of this current architecture, that is the ontology based on industry foundation classes. It's in ISO standard. We have also an OWL version of this ontology that is named IFC OWL. Also, I was lucky enough to contribute to this ontology. We know that in the community of ontology there are, let's say, not very, let's say, good opinions about these ontologies, but still it has quite some pros, even if we have also relevant cons. The cons, of course, are that this ontology is not based, is not grounded on a solid upper level ontology, but still this is an ontology that is helping to address specific and practical engineering, industrial engineering problem. And so it's providing a level of details that is fundamental to make things work, and not staying just on a theoretical level. Also, I would say it's quite largely used. How can we classify this ontology? I think it's a mixture of the whole pyramid of ontology. So it's both a top-level ontology for some parts, but also a domain-independent mid-level ontology, and also there are some parts of, I would say, application ontology. And so this is indeed also a big problem of this ontology, that is really huge and not modular in its design. I would say that during the years I've started to use less and less this IFC OWL ontology, but still it's providing answer to many of the questions that I need to answer for my manufacturing application. Then we have something else that is, let's say, standard de facto, W3C ontology, so time, SOSA, and SSM ontology. I think we can classify them as mid-level ontology, probably, but I'm not so sure about this. We have other small, very lightweight ontologies that are domain independent, addressing UML state chart, definition of mathematical expressions, statistics, and object states and performance history. These were reused, and some of them I developed in the past. And finally, we have a layer of domain-specific ontologies dedicated to factory and control, system control aspects. Going to the latter part of this presentation, also a few details about practical details. So I've been working quite a lot also with the RDF repositories, so trying to exploit as much as possible also Spark technologies. In the slides, you will find a lot of links. So basically everything that you see in my presentation is available online in online Git books, but also GitHub repository. So I really encourage you to go through this material and exploit it as much as possible. It's one of our mission. Going to the end of my presentation, just a use case representing the problem of manufacturing system design. So here we have an assembly line producing self-closing concealed cabinet hinges for furnitures. The use case is about an assembly line with 19 workstations. As mentioned before, we have very heterogeneous data and mixed about building, product, production resources, and all the relations among these entities. And here is a representation of the integrated, interoperating digital tools. Also, these tools are more or less prototype tools that are, again, available online, freely available online. You can go and check how they look. One of them is on the GUI web to instantiate and explore ontologies via SPARQL queries. And the other one, WebJS, is a virtual environment, reconfigurable and dynamic, based on WebGL technology. So it's a virtual reality running in your browser. So it's a very powerful tool. And here you can see a demo of production system that has been fully modeled with the ontologies I was talking before. You can see also the links both to the virtual reality application and also to the scene, to the 3D environment that is running now in my slide. So you can also test by yourself this assembly system in your own browser without any specific requirements. So you can see also the level of realism that we can reach with these smart technologies. And here I am with the closure. The last few slides are about the other graphical user interfaces I was mentioning, but I think it's enough. You can find them clicking the links that you will find in the slides. So thank you again, and sorry if I was a bit late.
Thank you, Walter. No, that was okay. It's actually, we are perfectly in time, even though this timing is my own timing and not the workshop schedule. I'm happy with how things are going. I know the speakers are eager to answer questions, but please don't do it in the chat. We'll keep them for a live discussion later on. So with said this, let me now present Mauro Dragoni. He's a researcher at the Fondazione Bruno Kessler Foundations in Trento, and he's part of the Digital Health Research Center. His main research topics concern knowledge management, information retrieval, and machine learning, and they focus on the development of real-world prototypes. He has been working on a lot of international industrial projects, 130 publications, and so on. So quite a bit of experience. He started to work with Etsy in basically 2 years ago with the SAREF project, essentially working for extensions and conceptual modeling for it. I just remind the audience that a paper on SAREF won the Best Paper Award for its, I believe, was 2018. So a lot of interesting reasons to listen to the talk. Mauro, if you're ready.
Yes, sure. I hope can you hear me?
Yes,
well?
we can see the slides.
Perfect.
Yes.
Thank you very much, Stefano, for the kind introduction. I'm very glad to be here on behalf of Etsy for presenting this brief speech about the experience that myself and also the entire SAREF consortium did in the last years about the adoption of SAREF in general and in particular for within the industry environment. I would like to go directly on one of the main points around SAREF and in general about the use of conceptual models in industry, because since this question, so if the definition of a conceptual model could be a good trigger for the industry 5.0 transition, could be a quite straightforward question in the sense that so many times in the last 10 years, this kind of question or similar ones have been done because the adoption, the usage, or simply talking about the use of conceptual model within industry was an interesting topic to discuss. In the last couple of years, this aspect started to be more relevant also from the European perspective, because, for example, in the new framework, for example, in the Horizon Europe framework, and also in the new other frameworks that have been published in the last couple of years, also from the European Union, there is a more relevant attention on the adoption of standardization and interoperability aspects within all the initiatives that have been promoted. So industry is not an exception, obviously, from this perspective. So I want to dedicate part of this speech about just summarizing what SAREF is, because it's not like it's not a simple conceptual model, SAREF, because there are many ways for which we can describe SAREF, because beyond the conceptual model that has been published already almost 7 years ago and that you can find online, there is a complete ecosystem of features that can be exploited for contributing to SAREF and for adopting SAREF at a real world level. We provided a rich set of technical specification about what is behind SAREF and related to the different extensions of SAREF. There is a very user-friendly documentation that is available online about which is the core aspects of SAREF, as well as also to describe how different extensions of SAREF has been created and then has been also adopted in practice. Then, connected with SAREF, there is a complete repository for developers where we made available the entire conceptual model, together with the documentation, the list of the requirements, examples in which SAREF concepts can be adopted. And also in our repository, we have also a pipeline that have been recently developed, because it is an artifact that has been made available only last year or 2 years ago, more or less, that allows to validate all the modeling activities that are performed around SAREF. And then beyond the core aspect of SAREF. In the last years, a number of extensions dedicated to specific domains have been developed. Here in the picture, you can find 10 of the 11 ones, because I mean, beyond these 10 domains, there is a recent 11th domain that is the SAREF extension for the smart leaf domain, that actually is something that has been published only a few months ago, and which I was actively involved in it. And among these extensions, some of them are very focused on the industry environment. Obviously, not only the industry manufacturing ones, but also about the energy, wearables, automotive, etc. I'm one of the actors that worked behind SAREF, because a lot of people contributed to this in a journey that started in 2013. So when the idea of SAREF born, and the experience of building and adopting SAREF was quite rich. Was very rich for me. Even if I work with them only from a couple of years. Okay. But it's something. It was a journey that started from the vision of very people that even if these people changed on the way of this journey, the vision that has been developed since the beginning of SAREF obviously helped to keep all the work team very focused on the objectives. Indeed, the approach that has been adopted since the beginning was a very step-by-step approach, project by project, because the extensions have been developed, across several years in different moments, not in turn year by year, but depending on which were the need, the idea, and the requirements that came also from different domains of the industry that believed in the vision of SAREF, and that they decided to invest time for designing the requirements and for defining which were the aspects that could be modeled within the SAREF ontology. For example, the smart leaf domain is just the last sample domain that has been embraced by SAREF. The need of SAREF, wasn't a need that came from the desire of designing a conceptual model just for representing the industry domain. It was an explicit request from the industry, because there was a very close interaction with the industry from the beginning, because all the data models that have been all the conceptual models that have been developed in SAREF in the last years were built bottom up by starting from data models, protocols, and standards that already existed. Just for making an example, when I worked on the design of the conceptual models for the wearable domains, we together with other people, obviously, the work that we did. We start to analyze all the existing standards about the manufacturing of wearable devices, and starting from them, we gathered which were the main features, elements, characteristics, and things that were useful to model for a conceptual model. And this kind of strategy allowed to have a very iterative and interactive approach with the industry that, on the one hand, could be perceived as a bit expensive, since there was some overhead, obviously, because more interactions and work with the experts can lead to some waste of time, quoted, for agreeing about where to meet and doing things. But on the other side, the result better reflecting which were the wishes of the community. And at the same time, it created trust in the work that we did. And obviously, it increased the acceptance of the result of SAREF within the real world domain. Indeed, many people have been involved from the beginning, as I already mentioned. Not only who designed the model, but also all the stakeholders from the various domains, and also we extended. Actually, Etsy extended the team, because I joined later in the working team of SAREF, with many people that believed in the vision of adopting a conceptual models within real use cases. And this is it is a vision that also personally I agree with it. That collaborated as a main asset. So people themselves represented a very important asset for SAREF for supporting the adoption of the model in real world solutions. Then the support of the standardization was already at the early stage, because obviously the use of a very formal and expressive ontology was something that didn't guarantee the adoption from the industry. So this is the reason for which we started to involve from the beginning also the policymakers, like European Commission, for example, helping a lot us in understanding which were the strong demand of the market also. And then also all the standardization process that have been adopted for design the SAREF framework allowed us to evolve the models over the time. At each step, the consensus of what we did was always fostered also by neutral parties. So in the sense that even if we have the idea of making a very important impact of our result on real world, the consensus about the product was performed by research centers, university, etc., as neutral parties, and not seen as competitors in the market with respect to who supported us in designing our conceptual model. Just 2 slides for describing which are the outputs and the impacts that ontology that a model like SAREF can bring to the industry, ranging from supporting the standardization of some recommendations from different actors like IEEE, IoT, ISO, etc. And then also the use of conceptual model can lead to to make domains like the IoT one more interoperable, open new market opportunities, design new business use cases, etc., etc. And then obviously from the more real world impact perspective, one of the targets that we aim, main targets that we aim to achieve is obviously to increase as much as possible the deployment and the adoption of our conceptual models in different domains for the realizations of applications, services for improving the interoperability in connecting devices, etc., etc. And then obviously for improve market opportunities within the EU area, but not only limited to it, and then at the same time to increase as much as possible, which is also the acceptance from the industry and from the final, the end users of the work that we are doing, and that how this work can obviously foster its adoption within the general AI environment. So with this consideration, I want to close the speech for staying on time, and I want to thank you for the attention.
Thank you, Mauro. Thank you, all the speakers. Now, I will go through the chat and the question answering tab to recap a little bit at least the topics that have raised some question or interest in the discussion. Before that, in order to help people raise more questions, I will remind you the objectives of this session and so the presence, the reason for having our speakers here today. There are 4 main objectives that have been identified for having this discussion. Of course, there is the role of a competency question for ontology development and verification, and Michael did a good job of presenting this. There is also the reason that we need also to understand how to formally represent a competency question, how to validate them in a certain way, how we take the most advantage of this approach. So that I remember is one of the things that came out very early in the ontology research, and that's been, let's say the community has quite a bit of experience with that, but still there are question how to use them and how to understand them, especially formally. Maybe I may raise a question later on this. Then there is the other problem of the practical roles, the role that ontologies play in industrial applications. This is the reason for Walter Takai's presentation that I focused on manufacturing. So what is the practical role of ontologies? That's something that's not completely clear, or at least the people have different ideas about that. And finally, we need to understand advantages and shortcomings concerning the transition in industry from the legacy systems to ontology-driven information systems. And for all these 4 objectives, we have plenty of stimuli from the presentations. And now I invited the speakers to ask questions to each other if they wish. They are free to do it. But before that, let me go through what was already the topics that were already raised during the presentations. I go through, just for convenience, I go to the chat first. So there was a question to Walter. No, I'm going the opposite order, sorry. The first one was from Peter Klein, if I remember correctly. It was to Michael, and says, since you stress the analogy between software engineering and ontology engineering, are there ontology development methods around like Summerfield's requirement engineering and continuous integration? Yes, I think that's it. Michael, you already answered it, but maybe you want to do a public answer to this question.
Right. So the reason I kind of play up the analogy to software engineering is the sense in which you can think of these questions as playing almost a role of continuous change, right? Continuous testing. So just like in a software system where you have testing the daily build. You can automate these tests. I think that's a great way of doing that with the Competency questions. The idea is to kind of always understand, where you are going. Designing ontologies is goal directed, and by doing those kinds of methodologies, you can get a better sense of where you are all the way through, rather than say waiting, until the very end and finding you made a mistake. But to me, the whole idea here is to you're using the ontology for doing something, and that forms the heart of the test. And you want to understand, is this ontology that I'm working on right now, am I actually getting closer to my goal of actually supporting that task? Whatever that task is, whether it's natural language question answering and decision support, semantic integration of data sets, ontology-based search, whatever, that's what we want to be able to support.
Okay, if none of the other speakers wants to add something to this, you can also disagree, Actually, we should show that people do disagree in the use and role of ontologies, and also specifically the competency questions. It's hard to talk against Michael on this, but we could. There is another question on the chat, and now I invite people to use the question answering tab. So I will stop looking at the chat after this one. And this says, a question to Walter: did you think about coupling your approach to edge computing?
Yeah, I think it's very interesting and probably needed. In particular, in the first slide was mentioning, I was talking about also synchronization between real factory and digital factory. I think it's fundamental to exploit edge computing in particular for this goal. So in particular, if you want to exploit ontologies that are quite time and data consuming, it's something really needed to move as much as possible of the computation to the device that is generating data. And so absolutely I agree with you, Peter, that it's something useful. Personally, I've not been working yet on this also, if it's something that I would like to. So yeah.
Thank you. So since I'm going in order, we will have first the question that were raised by Michael's presentation. So let's be aware of this. So I'm moving now to Wei Wu. And his question is, the validation for ontology would be to perform experiments to check with models. We can also ask the person to ask the question on the lively. I mean, if you think it's not clear, Michael, it's up to you.
No, I think this is another great question, because we're actually working on some systems that are doing sort of like ontology learning in reverse, right? Rather than having a human generate tests and having a machine learn it, we're actually engaging in some dialogue systems where the theorem prover generates possible models and has the user classify them as a way of kind of saying, yeah, this is intended, no, this is not intended. Because a lot of times we're not really fully aware of what our intended semantics are. It's only when we see a mistake that we go, oh, wait, no, that's something I shouldn't have, you should always answer no to that question, or something like that. And so I really believe this idea of experiments or dialogue is kind of critical in that validation phase.
Stefano, can I say something? So it's
of course
it's a comment or question for Michael. So I would say I would love to have this kind of automatic check. So like they do in the real extreme programmers.
Yeah, exactly. Yeah.
And so a question, I'm not an expert, but I'd seen something about methodology named Alloy. Have you ever seen anything? Do you think it's something that is applicable to ontology validation?
I think the methodology of Alloy, definitely. I would like to see some environment like that. Whether you could use Alloy directly, that's an interesting point. Haven't explored that in detail, but definitely that methodology, using whatever theorem provers that we have available and whatever ontologies we have available. Yeah, you're right. That's the kind of environment we'd like to see.
There is another question, competency questions, that I think is quite interesting. So you should give a public answer to this. Essentially, can we divide them in types? And probably we should ask what kind of types are most useful to discriminate in this case.
Yeah, and actually, I like Walter's presentation there. Like when he had those various kinds of Competency questions, say related to process planning, say in particular, right? That when you have those kinds of questions, you can think of them as playing as kind of, you could go two different directions given those questions. I mean, one would be to kind of use those questions as they are to determine whether or not your ontology has a rich enough signature, if you will, right? That if you're asking, what are the precedence relations in this process plan? Well, then what that's saying is, hey, you need to have some kind of precedence relation in your process plans, and so that's helping you pin down that signature. But then the other approach would be to say, okay, well, why are we asking this kind of question, right? So to refine it and to say, well, I would need to be able to answer that question, like what the precedence relations are, in order to answer another question, which would be, given some process plan, I performed steps 1 and 2, what can possibly happen next? And then that would force you to have enough axioms in your ontology to be able to answer, yeah, this is what can possibly happen next. And so you're on the one hand, you have some simple questions that are scoping the signature, and then you can have increasingly sophisticated questions that are again testing whether or not you have enough axioms in your ontology. And that's kind of the whole idea here of these questions is it's up to the user to figure out what those questions are. And as soon as you can answer the question, like I say, you're done. And if there's some kind of disagreement about, should there be this kind of precedence relation or that kind of precedence relation, if it doesn't make a difference in answering a question, then that's an irrelevant debate. Or you can turn it the other way around and say, well, no, we do want to make a distinction here. So then come up with a question that can actually distinguish between those possibilities. And then you can have this discussion about, well, which one would be the right way to go. But that's kind of the whole idea here is this, we're using this as a technique for eliciting semantics, intended semantics from people. And by posing it in the form of a question, we're hopefully making it something that can be both more objective, right? So that you don't have, endless debates, but also trying to automate in some way. So you can have a theorem prover do it, because there's no place to hide from a theorem prover. If it comes up with a proof, that's the way it is. That's what I like about software too. A bug is a bug. You can't run away. You can't wave your arms and say, that's what it's supposed to do. It's there, and you have to deal with it. You can always change requirements, and say, okay, that is a feature, not a bug. But that's the whole idea, is to try to take a lot of the debates in ontologies out of the arm waving, kind of opinion arena, and into the hard, this is the answer or not arena.
I noticed the skepticism in among logicians the first time that the first period that theorem improvements came out, and now there is a strong belief that everything they do is correct. Maybe we should balance that. But anyway, now I move to another question, which is still directed to Michael, but I ask all three of you to answer, because you all have had to deal with that. It says, what is the status? It's from Yves now. The previous question was from Melinda. To recognize who raised it. It was an interesting one, of course. And this is also very interesting. From Yves Keraron, I believe you pronounce. What is the status of a process in an industrial engineering ontology? And you all have experience in modeling processes, so you all have something to say here. I don't know who wants to start.
Well, it must be Michael. He made the start.
No, Walter first. You had the word process in your slides.
Well, it's what I can say. It's processes everywhere, and basically any standard about manufacturing or industry. So it's. I remember once Bob Young gave a presentation about it, and he was making a long list of ISO standard with different definition of process. So just starting from the definition, not even going to details that proper competency person could answer. So from my perspective, so it's trying to do things practical. I'm still waiting for the right answer. So I'm using something. It's derived from the ontologies I mentioned in my presentation, but it's not that I'm fully happy and satisfied with it. Just looking at, let's say, top level in the taxonomy of process. Then when you go even to the problem of defining a taxonomy of process, it's even worse situation, I think. And that's all. It's not an answer, I know. It's still an open question from my side. So,
who's next?
So I can add something. I can perfectly agree with what Walter said, because I mean, when you start to collaborate with people in industry for defining a model, in the beginning of the process, it's I mean, in the methodology for building the conceptual model, it's easy to define the first element of each of the conceptual model. The other part is how to proceed then when you need to define which are the how to say, which are when you have to define the more fine-grained element, and those are the connections, the relationships between them, and how you want to, how you have to define them in order to make your conceptual model usable in practice. No? From the methodology perspectives, I mean, if also in our case, I mean, from my personal experiences, we adopted quite old ontology engineer methodologies, since when you have to interact with the people coming from different domains with different knowledge, different expertise, they are still the most effective way for designing conceptual models. But yes, I guess that this is still an open challenge to address in some way, and not easy to solve, because when there are different people with different way of thought, etc., it's always difficult to try to mitigate all the differences, cultural knowledge, etc., for converging to, I mean, an effective final conceptual model. This is, I guess, that an effective methodology for doing this is something that have to be designed yet.
No, I like that point, Mauro, because that's in a way, one of the other challenges that we need to kind of be able to address is to say, how can we identify the similarities between us, and how can we recognize the differences, and then be able to support and integrate an environment where we share some things but don't share everything. And by kind of identifying then, well, what would distinguish us? So again, I'll just come back to my topic, the competency questions, right? It can be the case that if we all agree on the same set of questions, then we may sort of disagree on what the answers are, but at least we'd be able to understand, okay, here's how we are making different ontological commitments, because with respect to this question, I am answering it this way, and so I have a kind of a different intended semantics than you do. Or just even be able to say, well, actually, my ontology is not even addressing that sort of issue. That's kind of out of the scope. I don't even have those terms in my signature. So we do, in that sense, we don't agree on the questions. That would be a bigger divergence, maybe less opportunity to say integrate. But I think that the ability to be able to identify what we share and what we don't share, and then perhaps even why, that would go a long ways to supporting integration.
Thank you. I'm skipping some of the discussion that Michael raised with Weibo on the concept in physics, because they move the discussion to a little beyond the scope of this meeting, but it's I would just say that in principle, it is a principle of ontology that when you do ontological analysis, you do clarify the concept you're using. It doesn't matter what kind of concept they are. So that's I would say it's a principle. You have to accept it. It's part of what ontology means here. But anyway, so then I don't want to raise this beyond that. It's just an attempt to answer, and already Michael did in the chat. I move to Edlira, I believe, question. And this is also a question that we can state for everybody. It is essentially on the ontology evaluation stage. And we can state it theoretically for Michael, but also practically for Walter and Mauro, because you had to go through this somehow during your ontology development phase. So what can you report about this? And who wants to start? So, okay, I don't want to embarrass you. Let's this time let's make a Mauro to start, and then we go with Walter.
I was reading the question because I didn't get the point to the second part of the question. So if there is a difference with respect to verification and evaluation, or because I don't, when it is mentioned the question, which is the difference with respect to the previous ones, I didn't get.
It doesn't really matter, Mauro. Just
Okay.
state what you think is the important lesson we learn here about this, which is essential. I mean, in my experience, I even get people asking me, okay, now I did this one now, what should I do in terms of evaluation? And it's not trivial to answer, but since you did practical work also, theoretical work, just try to say what you did.
No, indeed, because if I have to, evaluate, validate, an ontology by applying the metrics that we know from the classic ontology engineering methodology is, okay, it's something that we usually do just for checking that, okay, the artifact that they did, it is in a working stage, no? So it's complete, it represents the domain, etc., etc., etc. No? The reason it works, we don't have overlaps between concepts, but this is a quite, how to say, more research-oriented evaluation. When you start to go in practice, for example, one of the things that we are doing now that actually it's not connected with Etsy. It's related to another research activity that we are doing here in FBK. The conceptual model that we are designing is something that will be actually used by an AI system for managing an AI platform, an AI ecosystem of services. And here, indeed, the validation with the stakeholders is something that is more complex in the sense that every time you check the ontology, every time you try to say, okay, we have the descriptions of the scenarios that we want to support, that are also the scenarios that led the design of the ontology. Every time there is something that is missing, something that has to be refined, and there is this sort of once you continue to go throughout this refinement process, the impression that I had in my experience is that this canonical iterative validation process can affect the trustworthiness that the end user can have in the conceptual model that you are designing, and in general also on the adoption of conceptual models for supporting real-world scenarios. It's complicated, and also here, if we want to do, for example, a comparison with how I can evaluate the quality of a database schema when I have to deploy it in practice. Also, the database schema, even if they are consolidated technologies, because it's 50 years that they are used, validating them can give you, a positive evaluation of the current picture of what you did. But saying that, for example, you reached the end, okay, in the sense that, okay, this is the final definite version of what I did is something that is very, very difficult to say, because from the practice, from their deployments of these artifacts, you can acquire further new experience and knowledge that will lead to refinements of what you did until that point.
Yeah, so a few words from myself, from my side. Well, it's as I said before, I don't have a really rigorous approach to this. More than verification, for me, it's, let's say, falsification. So as soon as I see that the current architecture of ontology module is not meeting the new requirements, we need to change something. So I'm not fully committed to any of the ontology modules that I've shown before in the architecture. So it's also, I'm not selling any of them, so I'm very free to to replace whatever I see is not appropriate anymore. For evaluation, for me, it's more about making things work. So if I see that it gets too complex to write a SPARQL query, for example, to answer a question, then it's clearly a proof that the ontology is not usable. Or if it's something so complex that I'm the only one that can understand it, also it's another way to evaluate the ontology. Also, I'm saying this because I also have experience with teaching with master thesis students. So we try to make these technologies as much accessible as possible and reusable. And so these are some of let's say, metrics that I'm using. And another way to evaluate is, for example, to see how much it takes to parse and get information from ontology. So I've shown the demo before about the 3D visualization of the reduction system. So if it takes 3 minutes to load the scene, then the evaluation says that it's a failure, of course. If it's something that is running only on a super laptop, then again, it's a failure. So I can say this about the evaluation stage. So again, like my whole presentation, it's mainly focused on the practical application and exploitation of ontology themselves.
Yeah, that's a good point, Walter. Right, so if I have my analogy to software, that things like competency questions are analogous to the functional requirements. In software, you also have non-functional requirements. So things like performance, portability, and reusability, for example, modularity and reusability. So these are often on kind of non-functional requirements you impose on a system. And I think that's something that maybe we haven't been addressing enough within the applied ontology community. Right, so how you can evaluate performance, right, with the right kinds of metrics, and a lot of people do that, right, and there's a lot of reasons why people use particular ontology languages to support better performance. But I think another key challenge, I think that's something that comes up even earlier, today in the discussion, say with IOF, for example, is one of the other reasons for adopting particular sets of ontologies is there's a sense in which some are maybe more reusable than others. But what does that really mean? I don't know if we really have kind of grappled with that question. How do we evaluate reusability? I mean, we talk about how to support reuse and maybe how to reuse and evaluate whether some to do that, to encourage it. But is there a sense in which we can say one ontology is more reusable than another, or are there certain criteria that we can say if you follow these conditions, you can be guaranteed to be reusable, in some sense? I think that's kind of a challenge we need to face there. How do you evaluate something like reusability?
Sometimes it's a question of the size of the community that uses it.
Well, no, but I guess it's a question, right? Is it something that is reusability, some kind of sociological criterion? Yeah. Is it an engineering criterion or not? I think that's kind of a key thing there, right? How do you test reusability, right? So if you use competency questions as ways of testing the semantic content of an ontology, right, whether you have enough axioms, is there a way of testing reusability? Or there's a way of testing performance, right? You can have benchmarks. You can do experiments with different sizes of data sets, right? And that people do a lot of work with that on the semantic web. But how do you test reusability?
But you need to have the right environment first, and probably the initiative of FAIR's principles applied to ontology might give at least the basics for then finding benchmarks for usability. But it can be technical or practical. So of course, that reusability involves a lot of different aspects. I agree with you. I move on to another question, this time from Milorad. And it's an interesting one. I have my own opinion, but I hold it and I let you answer it. Ontology can be considered, I believe, as a way to formalize how intelligent agents understand the surrounding world. So some ontologies pretend to be a Bible, some are technical manuals, and others may want to be a novel, I believe a kind of a storytelling. Okay, so this is just a statement. Now you are building ontologies to solve practical problems, and specifically in industry. So maybe I turn it into a question asking, which approach do you take? And how open are you to the fact that sooner or later you have to exchange your data with somebody else? Are you imposing your view, or are you trying to stay open in order to be ready, at least, to interoperate? This time I think Michael should start, because he gave the last answer for the other two questions. And then we go with Mauro and Walter. It's okay?
Well, I responded with a haiku in the Q&A.
Yes, I saw it.
But no, I think in some ways that's an interesting kind of observation, because you can almost adopt a kind of a very relativistic approach in the sense of I have a certain understanding, and I may even incorporate that understanding into the systems that I implement. And what I need to be able to do is to make that understanding explicit, so that other people, other systems are now aware of what I mean when I'm talking. And for humans, we manage to do this in natural language well enough. But with automated systems, I think we need to be able to, like I mentioned earlier, to the ontology, I can build my ontology that I say captures what I mean, and then you can use that as a way of understanding, oh, I see, this is different than what you were thinking, and here's the way in which it is different. So in a way, to adopt this, maybe it's not quite a novel, but it maybe is like a play, because I really think there's a dialogue going on there. And as long as we each design the ontologies that capture what we intend, then we can use that formalization of the ontology to compare, like I say, what we have and what we share, and how we differ. So I would say ontology is more like a play. Shakespearean.
Yeah, it's I totally agree with what Michael said. When you work with target users in specific domains, and you start to build the model in a bottom-up way, obviously the ontology that you are developing is very tailored with respect to the target user and the end user. So it does not pretend to be a Bible, in the sense that they are thought and to satisfy the need of your stakeholders, basically. It will always depend. First of all, which is also the ego of the people that are designing the ontology, because designing ontology by pretending to be a Bible for a specific domain, you need to be absolutely sure that you modeled everything about that specific domain. But it's what it is important, I guess, that when the conceptual model is designed, is to provide enough information for the community, rather than from the target user, about what you did, and which is the place of your ontology with respect to the world. And also maybe it would be good also to provide those indications about how it can be reused, as we mentioned in the previous answers, and extended. So it would be maybe the best way to proceed about towards the overall improvement of the quality and the completeness of the ontology itself. Yeah.
Thank you. Walter?
Well, I'll try to say something. So surely it's not a Bible, also because we would need continuous exegesis of it. So I think we cannot afford it. And from my side, what I try to do, in particular in the last few years, is to publish everything. So put everything online. I know it's not properly documented, so but is my approach. Also, I said during my presentation, everything can be found online. Me and my group of people, we are all together. We try to keep on documenting as much as possible, but Also, I said I'm not an ontologist, so I'm not so arrogant to impose anything to anybody. So
wow. I don't want to be an ontologist as well, then. if ontologist implies to be arrogant.
No, not in this sense.
We got the point. No, don't worry.
Yeah.
It was a joke. So now we have a question explicit for Mauro. This is from Arco Paul. It says, what is the right way to classify SAREF? Top, middle, domain levels? Is there a plan to align SAREF to one of the existing top-level ontologies like Dolce, Bafo, UFO, EMO, and you can go on for a little bit if you want.
Very, very nice question. Thanks. Now I didn't have to make the wrong question, because otherwise someone from ethics could kill me. I mean, I cannot classify. I guess that I cannot classify SAREF as a top ontology, in the sense that also the core module of SAREF refers to tangible aspect, tangible devices, artifacts, etc. So I would classify, and then it is very tailored to a specific domain already. Even if many concepts are quite general, in the sense that you have the concept of device, the concept of measurement, for example, but they are already thought and defined with a clear vision. So I would define the core module of SAREF as a middle level ontology, and then all the extensions as domain level, since each extension of SAREF is tailored to a specific domain. Planning for aligning it with the top level ontology, I never heard something about this. Now the alignments that we are doing in one of the projects that we are doing in this that are currently running is the alignment between SAREF and another conceptual model, that is the 1M2M based ontology, that was a similar model that was designed more or less just before SAREF. For harmonizing two kind of knowledge that have been built in parallel in the last years. This is the only mapping activity that we're doing, but no plans for mapping it with the top level ontology that are existing.
Thank you. Now, there is I skipped the question from Francesco Compagno because it was a clarification, I believe, and Michael answered in the chat. There is another question from Peter Kleine. He says, it's a question for everybody. If you work with engineers in order to construct an ontology for the domain, how do you cope with the implicitly clear requirements of those engineers? So essentially, to say, well, this is obvious, and it's hard to get some more positive attitude. That's my interpretation of the question. And he says, well, look, in the case of materials and modelers, we have this problem. We face this kind of problem. So how do you cope with this implicitly clear requirements from domain engineers? If you have an experience with that.
You have to make it explicit.
Okay, so you have to insist. No, it's okay.
I've been working on playing the role, both roles, let's say. So both the engineer and the ontology developer, let's say. So it's I understand and agree that it's challenging. Also with Stefano, that is a real ontologist. We've been working on it. I understand that it can be difficult sometimes to do this, and but indeed, you need to keep on talking and explain yourself as soon as you're able to formalize. So, if a real ontologist in the end can understand you, then it's a good step forward, I would say.
I think also using actual, real data sets. I think maybe sometimes we kind of gloss over that, but actually looking at the nitty gritty. If a material, material modeler wants to, share some data with, some other member and some other engineer on the team, what exactly is that data that they are sharing? What does it really look like? And how would a lack of semantic integration manifest itself, right? What would a possible misunderstanding be, or potential failure to integrate look like? I think by kind of getting really brutally explicit about what exactly that data is, I think we could start answering that question too.
We are closing. Mauro, if you want to say something quickly.
I can only agree with both of the answers that Bart and Michael gave to this question, because I mean it's the actual way in which we can proceed for mitigating the interactions with with engineers that sometimes it's not very easy to manage. But anyway,
thank you. So I can only add that this is an effort we have to do, because we are moving from a traditional way to modeling to an ontological-based modeling. And that requires a different way to think of what your modeling are, your concepts. And so, well, the question that Peter raised is an important one, but it applies in this transition phase, let's say. We hope it's a transition phase at least. So now, if you want to insist with the questions, you have to move to the lounge, because it's the break time. I thank again the speakers, everybody that attended, especially those that made those interesting questions. I could not raise mine, but that's my problem, so I remain with a lot of curiosities. And I hope everybody enjoyed the presentation and the discussion. Thanks a lot. Bye-bye.
thank you.
See you. Bye-bye.
Bye. Bye.